Okay, so with stats, our and means multiply, and our or means add. So just like before, if I read the question and I decide I want something or something, I'm going to add them together. Now, you can always use a combination of and or when you want more than one thing. And when we're doing all of our probability sums, order matters. So sometimes we want a red one first and then a blue one. You're going to multiply. Or we could have a blue one and then a red one. So you're going to then add and multiply for all your different combinations. So if we look at some examples, our first one, we have James and Sarah both taking the music exam independently, and the probability that James passes is 3/4, and the probability that Sarah passes is 5/6. And they want to know what is the probability that either James or Sarah passes, but not both. So we want the probability for James or Sarah passing. Now, that's going to mean that we're going to have the probability that James passed and Sarah didn't pass, because one of them has to pass and one of them must fail. Or we could have the probability that Sarah passed and James didn't pass. So we're going to multiply and add, because we want James passing and Sarah not passing, or, remember that's or, for our add, Sarah passing and James not passing. So that's going to mean the probability of James passing is 3/4. And Sarah not passing is going to be 1/6. So we multiply those. Then we add Sarah passing as 5/6. And so we multiply James not passing is 1/4. So if we type that into our calculator, we get an answer of 1/3. If we look at the next example that we have Simone and John playing darts, and the probability that Simone throws a bullseye is 0.1, and the probability that John throws a bullseye is 0.2. Simone and John throw 1 dot each, and we now need to find the probability that exactly 1 bullseye is thrown. So they say exactly 1, but they don't say who. So that means it could have been Simone or John. So if we want the probability for 1 bullseye, it's going to mean that we're going to look at the probability that either Simone threw the bullseye and John didn't, or Simone didn't and John did. So either Simone is going to throw it and John is not, or it's going to be that Simone didn't and John did. So we look at those. Simone's probability of throwing the darts is going to be 0.1 to win. So 0.1 times John not throwing the bullseye would be 0.8, because it's 1 minus that. Or, so we add, Simone not throwing it would be 0.9, because it's 1 minus that, times John throwing it as 0.2. So if we type that into our calculator, we get 0.26. And if we look at the next example, we have got Curtie and Justin doing their driver's tests, and each learn to drive separately, so the results are independent, and the probability Kurtie passes is 0.6, and the probability that Justin passes is 0.4. And we need to calculate the probability that at least one of them passes. So because it says at least one, that means it could be one or it could be both, because we have to have all the possibilities, because it says at least. So the probability for at least one would mean it's the probability that it could be Kurtie passing and Justin not passing, because that would mean one of them did. Or it's the probability that Kurtie didn't and Justin did, because then that's the other one passing. Or it could mean both Kurtie and Justin are passing. So the probability for Kurtie passing is 0.6 times the probability of Justin not passing is 0.6. Or, so we add, Kurtie not passing is 0.4 times Justin passing is 0.4. Or, so we add, Kurtie passing is 0.6 times Justin passing is 0.4. So if we type that into our calculator, we get a final answer of 0.76. And then exactly one of Kurtie and Justin passing, that means only one of them. So the probability for just one passing means it's got to be Kurtie passes and Justin doesn't, or Kurtie doesn't and Justin does, because that's just the one of them. So we're going to do the same thing as before, except now we're only going to use Kurtie passing and Justin not, or Kurtie not and Justin passing. So if we fill those in, 0.6 times 0.6 plus 0.4 times 0.4 gives us a final answer of 0.52. Okay, the next one, we now have 3 different houses, and in each house, all the people living there are classified as children, parents, or grandparents, and they give you the number of each in each house. Now they say a house is chosen at random, and then a person in that house is chosen at random. So now we need to calculate the probability that the person chosen is a grandparent. So we want just grandparents, but we also have the added probability of choosing the house. So we want the probability of being grandparents. So the probability of being a grandparent from any given house means it's going to be the probability of choosing house number 1 and being a grandparent, or it's the probability of choosing house number 2 and being a grandparent, or it's the probability of choosing house number 3 and being a grandparent. So, if we look at the probability of choosing the houses, there's 3 houses, so the probability of choosing house number 1 would be 1 over 3. So we've got 1 over 3 times grandparents in that house. There's 2 grandparents to choose from out of a total of 7 people living in that house. Or, so we add, choosing house number 2 has a probability of 1 over 3, because there's only one house number 2 out of the 3. And the grandparents in that house, there's 3 to choose from out of the total of 7. Or, choosing house number 3, the probability is 1/3 again. And there's only 1 grandparent there out of a total of 2 people. So if we type that into our calculator, we get an answer of 17/42, or 0.405. Okay, so for our next question, it's quite a longer one. We have Rachel and Anna playing badminton, and each game results in either a win for Rachel or a win for Anna. The probability of Rachel winning her first game is 0.6, and if Rachel wins a particular game, the probability of her winning the next game is 0.3. But if she loses, 0.7. But if she loses, the probability of her winning the next game is 0.4. Now we need to find the probability that Rachel wins 2 games and loses 1 out of the first 3 games. So we want the probability that she wins 2 and loses 1. So now order is important because she can win and then lose, or she could lose, win, and win, or she could win and then lose and then win. So if we look at those in terms of our probability equation, we want the probability that she wins and loses, or probability that she loses and then wins, or the probability that she wins and loses and wins. So our probability that she wins first. It says here that the probability of Rachel winning her first game is 0.6. So if winning first, 0.6. If she wins a game, her probability of winning the next one is 0.7. So she won the first one, so the probability of her next one is 0.7. And then after she wins that one, she's going to lose. So it says the probability after she wins a game, the probability of her winning the next one is 0.7. So she won the game, but then the next one she lost. So if the probability of her winning is 0.7, that means the probability of her losing is going to be 0.3. So that's going to be times 0.3. Or, so we add the probability of her losing her first game. So the probability of her winning the first game is 0.6. So her probability of her losing the first game is going to be 0.4. Now she lost that game, and then she's going to win the next one. So it says if she loses, the probability of her winning the next game is 0.4. So she lost, so her probability of winning next would be 0.4. Then she won this game. So if she wins a particular game, the probability of her winning the next one is 0.7. So now she's going to win the next one, so that's going to be times 0.7. Or, we're going to add her probability of winning her first game is going to be 0.6. Then she's going to lose the second one. So if she's won the game, her probability of winning the next one is 0.7, but she lost it. So that's going to be 0.3. And now she's lost that game, so her probability of winning the next one is going to be 0.4. So if we type this into our calculator, we get an overall answer of 0.31. Okay, and if we look at our next question, we have James has a fair coin and a tetrahedral die with 4 faces, numbered 1 to 4. He tosses a coin once and the die twice. X is defined as if the coin shows heads, then X is the sum of the scores. And if the coin shows tails, then X is the score on the first throw of the die only. And we need to show that the probability that X equals 3 is 3 over 16. So because we are rolling dice twice, and if we get a head, it's going to be the sum of the scores, the easiest thing to do is to put all of our information in a table for when we're rolling dice. So we've got 1, 2, 3, 4 sides for our first dice, and 1, 2, 3, 4 for the second one. So now X says that we're going to sum the scores on the 2 dice when we roll them. So 1 plus 1 is 2. 2 plus 1, 3. And we keep going like that, and we fill out the whole table just like that. So those are all of our numbers summed together in the table. And to work out our probability, we want to find where the answer is 3. So now we look in the table and we can find all the 3's, and there's only 2 of them. So the probability of getting a 3 here would be 2 over the total number in the table, which is going to then be 16. So that's getting all the 3's. But now we need to have all the possible options for our answer. So to find out the probability that X equals 3 means it's going to be the probability that we chose heads first and got the 3, or we could have flipped and got tails and a 3. So the probability of choosing heads, when you flip a coin, because there's only one head out of the 2 sides, it's going to be 1 over 2, times the probability of getting that 3 when we sum the scores is going to be the 2 over 16. Or, so we add, getting tails is also going to be 1 over 2. And if we got tails, that means that it was the score on the first throw only. So there's only 1 3 on our 4-sided dice. So we're going to get 1 out of the 4 sides to get our 3. And if we type that in our calculator, we get the answer of 3 over 16, which is what they told us to show. Okay, so in our next example, we have a box containing 2 green apples and 2 red apples. Apples are taken from the box one at a time without replacement. And when both red apples have been taken, the process stops. With random variable x is the number of apples that have been taken when the process stops. So we need to show that the probability that x equals 3 is a third. So the probability that x equals 3 means we took 3 apples from the box, and we stop when 2 of them are red. So that means we could have had a green apple, and then a red one, and a red one. Or we took a red one, and then a green one, and then a red one. We can't just take a red one and then a red one, because then the process would have stopped with only 2 apples. We had to have 3. So those are all of our possible options to give us just 3 apples. So now for probabilities, the probability of choosing a green apple first, there's 2 green apples out of the total of 4 apples. And so we multiply. Then we pick a red apple. So there's 2 red apples out of 3 apples left only, because once we took the green one, we didn't put it back. So now there's only 3 left in total. And then once we've chosen 1 red one, we didn't put it back, so that means there's only 1 red one left out of the total of only 2 apples, because each time we take it away and we don't put it back. Or if we start again and we pick a red apple first, there's 2 red apples out of the total of 4 apples. Once we've picked that 1 red apple, then we're going to pick a green apple, and there's 2 green apples out of the 3 that are left. And then our last red apple, there's only 1 red apple left out of the remaining 2 apples. And if we put that in our calculator, we get the answer of 1/3 that they wanted us to show. And then for the next one, now we're looking at boxes of sweets containing toffees and chocolates. Box A has 6 toffees and 4 chocolates. Box B has 5 toffees and 3 chocolates. And box C contains 3 toffees and 7 chocolates. So one of these boxes is chosen at random, and the 2 sweets are taken out, one after the other, and then they're eaten. So they're also not put back, just like the apples. And we need to find the probability that both of them are toffees. So we want the probability of having 2 toffees. That means we could have chosen box A and gotten 2 toffees, or box B and 2 toffees, or box C and 2 toffees. So we want the probability for either choosing A, and then we picked 1 toffee and then the second toffee, or box B and the 1 toffee and the second toffee, or box C and the 1 toffee and the second toffee. So looking at the probabilities, there's 3 boxes and there's only 1 box A. So the probability of choosing box A is going to be 1/3. Out of box A, there are 6 toffees out of the total of 10. So choosing a toffee means there's going to be 6 out of 10. Then once we've chosen that toffee, we've eaten it. So now there's only 5 remaining toffees left out of the total of 9 in the box. Or, so we're going to add box B. There's only 1 box B out of the 3 boxes. In box B, there is 5 toffees out of a total of 8. Now, once we've eaten that toffee, then there's only 4 toffees left out of the remaining 7. Or for box C, there's only 1 box C out of the 3 boxes. And in box C, there are 3 toffees out of a total of 10 in the box. And once we've eaten that toffee, there's only 2 left out of the remaining 9. So if we type that in the calculator, we get an answer of 53/210, or 0.25. Okay, and if I look at the very last example that I have the probability that Henk goes swimming on any given day is 0.2. And on a day when he goes swimming, the probability that Henk has burgers for supper is 0.75. Now, on a day when he does not go swimming, the probability that he has burgers for supper is X. And the probability that Henk has burgers for supper on any day is 0.5. And we asked to find x. So we're given the probability that Henk has burgers for supper as 0.5. Now when he has burgers for supper, it means he either went swimming and had burgers, or he didn't go swimming and had burgers. So the probability of having burgers for supper overall means it was the probability of swimming and burgers, or the probability of not swimming and burgers. So the probability that he has burgers for supper is 0.5. The probability that he goes swimming on any day is 0.2. And on that day when he goes swimming, the probability of him having burgers is 0.75. Or so we add. The probability of him not going swimming on any day is going to be 0.8, because it's going to be 1 minus 0.2. And then when he doesn't go swimming, the probability that he has the burgers is x. So now I have an equation that I can solve for x, because I have 0.5 equals 0.15 plus 0.8x. And if I move that over to that side to subtract, I get 0.35 equals 0.8x. And now to get x on its own, I'm going to divide my 0.35 by the 0.8. And I end up with an answer of x is 0.438. And now I've solved for x.